Hello everyone and welcome to another episode of the Quantum Hidden Champions. In today's episode we are going to talk about another company. This time it's maybe a little bit less obvious how they actually match into the quantum space, so it's going to be a bit more of me talking and less showing their website, but let's jump right into it. Today's company is going to be ASML. So here we are on the website of ASML. It says changing the world 1 nanometer at a time. ASML gives the world's leading chip makers the power to mass produce patterns on silicon. And then here we see one of the machines, the annual report 2024. I'm recording this September 2025. There's a video here, something about the ASML team, 60 locations, and so on. So let's take a step back and talk a little bit about what ASML is actually doing. So ASML is one of the leading, or maybe even the world's leading manufacturer for lithography equipment. What is that? Well, in all of the chips that you have in your phone, in your computer, whatever, like everything that is running on high performance computing chips, you are basically using structures of transistors inside a chip that have scales of a couple of nanometers. Now these chips, they can actually be mass produced, and usually the players that are mass producing them, you might know them. They're called, they're companies like Intel, TSMC, there's other ones like Samsung, so and other players across the globe, right? So they have these clean room facilities. In the clean room, they produce these wafers, or they work with those wafers. They do processes on these, and in order now to come from a wafer, which is basically just like a round silicon, a big piece of silicon, like a crystal, to come from that crystal to a transistor, you need to do different steps. Like these could involve etching step, where you remove part of the silicon. It can be deposition steps, where you deposit different types of materials, could be metals, could be insulators, everything that you basically need to build those transistors. Could be doping of the crystal itself, so you introduce impurities in order to introduce charges into you introduce impurities in order to build structures inside those crystals. Now, what is the role of ASML in all of this? Well, basically every time that you do such a step, you need to perform a lithography step. In a lithography step, you basically put a pattern, like a structure, on there. So think about like two metal electrodes that you want to have sitting on top of a piece of silicon, which is kind of doped with different materials such that you can build a transistor. Now these contacts, they have to be nanometer scale in order to later on build these nanometer transistors. And now how do you actually do that? Well, traditionally what people used to do is they would make masks, like for example a piece of metal that has like a slit in it, and then if you shine light on it, you can basically project this slit onto, for example, the wafer. Now you can use what is called a photoresist, which basically reacts upon being exposed with light. And that's how the lithography is basically being done. You cover your whole wafer with this photoresist, then you have this mask and you shine the light through it and thereby expose certain areas. And now if you remove the resist, it only removes partially, namely either by the part that has been exposed or the part that has not been exposed, depending on what type of resist you're using. And then what you're left with is basically this structure. And well, you can actually use this technology in order to create very, very, very small patterns. And that's basically what ASML is an expert in. They create machines that use a very specific type of light, which in this case is UV, ultraviolet light, and there's also extreme ultraviolet light, EUV, and you actually need this specific type of light in order to create these very small structures, because at the very beginning, when you start with like big structures, you can use basically all types of light. But the smaller it gets, the more you come to the more you reach the point where the quantum property of light actually starts to play a role. And this point has actually been reached, and that's why you need to actually have those machines that work on this ultraviolet radiation in order to create these very small patterns. Now, what is the relation of all of this into the world of quantum? I think there is a couple of different ones, and today, or in this video, I actually want to explain my thoughts a little bit on where this could play a role. So first of all, there's of course the obvious one, which is ASML is a big player in the lithography space, which means basically if you have some quantum technology, be it photonic, be it superconductive, be it silicon spin qubits or whatever, everything that is basically that is based on semiconductor technology, on solid state technology, this is going to rely on machines that can do lithography. So, for example, when I was working on this superconducting stuff during my PhD time, I would of course create those samples together with my research colleagues in a clean room. So we had a clean room facility very similar to where you build chips. We were wearing these bunny suits with like the masks and all the clean room dresses and the gloves and everything. And we were basically using the same machines that are nowadays being used in order to make computer chips, but we were using them to create those quantum materials, to create those quantum chips, which we later on put in the cryostat, and so on. So basically, this new industry, which might, let's say, occur at some point, which might rise up at some point, there's a certain probability that actually this will rely on the technologies that have already been built for the semiconductor industry. And there's very obvious ones, like for example, think about spin qubits, where you can basically use a silicon wafer where you put metallic gates on top. Of course, there's a lot of other stuff going on to create this two-dimensional electron gas and so on. So you need a lot of new stuff as well. But in its core, the idea is use the existing CMOS technology that is already out there, that is scalable, that works for today's computer chips. Use that in order to create those spin qubits. And now for the spin qubits, these very, very tiny structures, they're actually quite important. That has to do something with the effective electron mass, which an electron has when it is confined in silicon. That kind of tells you how small you actually have to confine the electron, or how small the space is where the electron has to be confined. And that basically tells you have to create these nanometer structures in order to really be able to do quantum computing with such a chip. But again, there's also other stuff like superconductors. And even if you're looking at those integrated waveguides, where you have like optical waveguides integrated into a wafer, all of this basically relies on the process of lithography, which means ASML would play a role. But there is also a second part, which from my point of view is interesting about ASML, and that is they create those machines. I showed you here on the website, this one. These are really, really expensive machines. They're really big, so it's like a really complex machine. It uses all types of complicated stuff. Believe me, like I've been visiting ASML once. They showed me around a little bit. They explained what they're actually using for this EUV stuff. So in there goes like a very specific type of laser that is being used to create those light beams that are being used for the lithography. Then you have a mirror which is in there, which is basically a unique thing that is only being produced for ASML and can only be produced by Zeiss in Germany, all that stuff, right? So there's a very, very complex stack of technology that goes into these machines, and actually ASML kind of has a very close relationship also with its suppliers, and has a very their job is to manage this very complex stack, because they cannot build everything by themselves, right? Because for that there's too much rocket science going into these machines, even though they are not building rockets, but like very complex stuff going into these machines. And they have to understand every single component and put them together into what later on becomes this lithography machine. So what does it mean? There's a lot of complicated stuff which has to operate on nanometer scale, operate on specific wavelength, and so on, which can play a role in this whole quantum technology revolution. So not only quantum computing, but also in the communication, maybe even in the sensing space, because they have to move these wafers at nanometer precision. So there's like a lot of complex stuff going in there. And all of this technology stack, of course, also profits from ASML generating business. So there's a high chance that part of this tool chain that ASML is using is actually also relevant in terms of this quantum technologies being developed. Now, the third thing that I find very interesting about them is the talents that they have, the people that are working at ASML. I just know a couple of them. Some of them, they work there. Some of them used to work there. So, and these were all basically former colleagues, people that either I studied with or that I got to know during my studies, that I would collaborate with. So there's a lot of people that have this background in quantum technology, that have been working in those quantum technology labs. And there's a high chance that if there's a company that has an understanding, or if you are looking for companies that have an understanding in their staff of how quantum technology works, I think within Europe, ASML is probably one of the key players there, because they have so many people working for them that actually have a degree already in something that is related to quantum technology. So there's a high understanding that if things are taking off, they can actually also kind of steer a department into that direction, get the people together that they need in order to create products for this market, because they can have a very good understanding generally of that market. And I mean, that is also a very important thing, because if you, for example, look at what ASML is doing right now, they have just announced that they're going to invest into Mistral AI, which is one of Europe's leading large language model companies. So they're already taking a step into AI, and there's a chance that at some point they might also do a step into quantum. So for me personally, ASML is one of these companies that you might not think of at the first thing when you think about quantum technology. Also, if you look at their website, you will not see a lot in this direction. So you see it's about the company. You can learn about what ASML is doing, what they are doing in the semiconductor space. So it all looks like very traditional business in a way, like semiconductor business. You see their scale. You can learn about like what open positions they have and so on. But you don't really see a lot about quantum. And I mean, that's because that's not their main business. But again, for the 3 reasons that I've said before, I think they're one of the companies to keep on the radar when talking about quantum technology. And with that, we are already at the end of today's video. That was a short one. As always, make sure to stay hydrated and see you in the next one. Bye bye.